Mars seems to be a promising nearby place to search for life beyond Earth, but the red planet has held on stubbornly to its secrets. Despite decades of investigation, and even some exciting results, sure signs of life have yet to emerge. Now the long search for life on Mars could be on the cusp of bearing fruit, however. Scientists think that the minerals in Martian clay could be the key to finding signs of ancient life on the red planet. The European Space Agency, an organization devoted to space exploration, is currently working toward launching its ExoMars Rosalind Franklin rover to Mars to search for signs of life. And according to a statement from the space agency, the rover is now aiming to land at Oxyplanum, a depression on the Martian surface where it's thought that water was once plentiful. There, scientists think that they might find major clues in the hunt for life in the basin's clay. Scientists have spent years searching for signs that life once existed on Mars. It's thought that water on Mars evaporated around 3 billion years ago, but before then, the planet likely had a more substantial atmosphere and water flowing in rivers and into lakes all across its surface. Because of the planet's history, many scientists think that it's most likely that at some point in the ancient past, the planet must have supported life. While this has yet to be confirmed, in 2025, scientists found what is currently thought of as the strongest possible biosignature or physical evidence of life on Mars. In a new study, researchers have found extensive clay deposits at Rosalind Franklin's proposed landing site. They found this clay to reach roughly 186 miles outward from Oxyplanum, stretching as far as a Martian valley called Moth Valleys. To spot the clay, they first studied the planet from orbit. Researchers used the Omega instrument on the Mars Express Orbiter and the Mars Reconnaissance Orbiter to explore the minerals and rock layers on Mars between Oxyplanum and Moth Valleys, finding mineral layers at both sites as well as markers showing changes in water chemistry over time. These observations add to other studies pointing to water on ancient Mars. With European Space Agency's upcoming rover, some scientists think that the clues to life on Mars could be hiding in this clay in the Oxyplanum region. By landing at Oxyplanum, scientists hope to uncover a large-scale process that shaped ancient clays across Mars. Scientists think that it's possible that the area of Oxyplanum could have once been home to a body of water as big as an ocean, or the region could possibly have experienced incredible flooding some 4 billion years ago. Targeting the oldest deposits in the sequence makes the potential implications for the geology and early climate of Mars very relevant for the Rosalind Franklin mission in its search for life. While scientists have never confirmed life off Earth, and it could be different from the life we know, as far as life on Earth is concerned, water is a necessary ingredient. The Rosalind Franklin rover is projected to launch to the Red Planet in 2028, and the rover will be part of European Space Agency's ExoMars program alongside the agency's Trace Gas Orbiter, which is already traveling around Mars. The Rosalind Franklin will have a drill, allowing it to explore below the planet's surface as the pair work together from orbit and on the Martian surface to hunt for signs of ancient life. The drainages in this observation are part of Hebris Valls, an outflow channel system likely formed by catastrophic floods. Hebris Valls is located in the plains of the northern lowlands, just west of the Elysium volcanic region. Individual channels range from several hundred meters to several kilometers wide and form multi-threaded patterns. Separating the channels are streamlined forms, whose tails point downstream and indicate that channel flow is to the north. The channels seemingly terminate in an elongated pit that is approximately 1,875 meters long and 1,125 meters wide. Using the shadow that the wall has cast on the floor of the pit, scientists estimate that the pit is nearly 500 meters deep. The pit, which formed after the channels, exposes a bouldery layer below the dusty surface mantle and is underlain by sediments. Boulders several meters in diameter litter the slopes down into the pit. Pits such as these are of interest as possible candidate landing sites for human exploration because they might retain subsurface water ice that could be utilized by future long-term human settlements. This observation covers the inside of an impact crater on the northern plains of Mars. The dark, undulating dunes seen here sit atop a colorful surface of exposed bedrock. Based on the crater's diameter of roughly 25 kilometers, these rocks may have been previously buried over a mile beneath the surface. The varying colors likely reflect diverse mineral compositions. The Compact Reconnaissance Imaging Spectrometer instrument, also on Mars Reconnaissance Orbiter, has detected different minerals in the neighboring larger Mickout crater, whose rim lies about 50 kilometers southeast of this image. Excavated by impact, the colorful rocks here remain visible in part thanks to the winds that shape the overlying sand dunes, which help to sweep the crater's center clear of surface dust.